Hello everyone, my name is Ishan Sagar Jogalekar, 19 BC 2250. I am a student pursuing BTech in Computer Science and Engineering in Vellore Institute of Technology, Vellore. This video focused on our project with my friend Siddharth Chatterjee, 19 BC 2249 for data structures and algorithms in 3rd sem under the guidance of Professor Kasur Ahmad P. Sir.
Hello everyone, I am Siddharth Chatterjee, registration number 19BC 2249. I am pursuing my BTech from Vellore Institute of Technology, Vellore in Computer Science Engineering core branch. This video is part of my project Traveling Salesman problem in DSA data structure algorithm in 3rd sem in fall semester 2020-2021 under the guidance of my faculty Professor Kasur Ahmad P.
Hello everyone, this is Siddharth and I am going to walk you through our project, the traveling salesman problem, till the implementation details and how using Google Maps we are describing a real world scenario. So the abstract basically answers the famous question regarding the traveling salesman problem. Given a list of cities and distances between each pair of cities, what will be the shortest possible route that visits each city exactly once and returns to the origin city? Now, the traveling salesman problem is a part of the computational complexity theory, and it is termed as an NP-hard problem, where NP means non-deterministic polynomial timeliness problem. A simple example of the NP-hard problem is a subset sum problem, which is quite famous in mathematics. The TSP is still by far the most intensively studied problems in optimization, and it is even used as a benchmark for many optimization methods. And even though the problem is computationally difficult, many heuristics and exact algorithms and even some genetic algorithms are known which can solve tens of thousands of cities completely. Even problems with millions of cities can be solved. So our aim was basically to consider a ground level scenario where company Surakshit, we have named Surakshit, supplies water filter devices and carries out installation services and requests, service requests and etc. etc. So it has number of salesmen in certain geographical area, and it has the salesmen to engage to carry out the services from city to city. And as the question suggests, we have to go visit each city exactly one and return to the origin city. So the explanation is mentioned here. We are trying to minimize the cost of travel, and therefore we implemented cost matrix table. What we do is we first ask the user the input for the number of cities. We can see the number of cities is 4 here. We have entered. Similarly, we are trying. The next part will be to enter the cost matrix in the form of rows, row by row, as its number of cities is 4, and we visit each city exactly once and return to the origin city. It will be 4 by 4 matrix, so there will be 16 elements. So we enter the elements of row 1, 4 by 4, 4 is 8, 12, 16, as simple as that. So we first derive the cost matrix by calculating the absolute distance and many other factors. And this is quite important because we are considering an asymmetric graph for TSP. As you can see here, this is there are 5 cities here: x1, x2, x3, x4, x5, and there are huge number of arrow marks you can see depicting the distance between each city, and you will notice that it is different when you go from x1 to x2, and maybe you go from x2 to x1. So x1 to x2 is 5 here, x2 to x1 is 9. Why? Because there may be certain factors which may be deciding the cost matrix, and it's not always the absolute distance. There may be reasons like traffic, tolls, road tolls, bad weather, climate, road accidents, etc. etc. So then we enter the elements row by row, and what it outputs is the route the salesman should follow, the optimum route, as well as it also outputs the minimum cost of travel. So here, once the person goes from city 1 to 2, 2 to 4, 4 to 3, 3 to 1, the cost for travel becomes 35. So our objective is to make our algorithm quite precise and functional, with respect to like our problem scenario, and try to reduce the time complexity as much as possible. And we have also looked into different data structures which can be implemented, but so as to come up with a very reasonable and the best solution, which is the applicability. What basically means it should be relevant to the aim. So in case we have considered the problem scenario for our applicability, and we are actually going to use the dynamic programming method for help card method using dynamic programming. So the introduction basically describes how many different types of algorithms are used to solve the TSP, exact, heuristic, approximation, lower bound, etc. etc. So here, this is the theory part, the Hamiltonian cycle and all. There is a non-negative cost C, I, J for travel from city I to city J. Now the goal is to find a tour of minimum cost, and we assume that every two cities are connected. So we know the distance between each and every city, and vice versa, the reverse journey too. So it's like consists of all the Hamiltonian cycle, the directed and undirected graphs and stuff. And often the model is a complete graph. So as I said, each pair of vertices is connected by an edge. Everything is connected. So we can try all permutation combination, but it will be like huge for impractical even for 20 cities. So our health curve algorithm solves the problem in O n square to the power n. It's quite a less time complexity. So this is like our details. Alternative methods and the drawbacks. Actually, so what the first method is obviously, as I said, the factorial method. Even for 30 cities, it becomes a very huge number to calculate. So this is the number of possible paths which you can visit. So this does not make sense. Branch and bound method. It is usually used in this kind of optimization, mathematical optimization. It causes a combinatorial explosion. It's a top-down recursive research, branch and bounds, branching and bounding. The concept is here, we traverse the root node and stuff, and we apply the TSP here. We break it down into AB and routes without AB, and then again from a part or section of the root, we break it into ones which contain that section and which does not contain the section. So tools with AB and AC, tools with AB but not AC, and so many other possibilities. Drawback is simply it is because we limited to a small size network, and problem of large network solutions for search space goes exponential and stuff. There is also an exhaustive search. It also has many drawbacks. As I said, there is a chance of combinatorial explosion, as in the case of factorial method, and this is a brute force method, and it generally does increase the time complexity by a very short margin. So our proposed method is the health card algorithm using the dynamic programming. In this, what we do is we define different parts of our algorithm. We break our problem into different sub problems. We define the base code of each and we enumerate functions. We call down each and every recursive function. So basically, every subpath is a path of minimum distance. It is itself of minimum distance. So we calculate subpaths of all paths. That's what we do. And time complexity is O n squared to the power n. The advantage of proposed method is it offers faster execution and exhaustive enumeration. And it there's also cutting plane algorithm, but it depends on experience, and therefore health card is better because person who won't know how to cut the plane and cannot apply this method cutting plane algorithm. As I said, branch bound is not good for solving the large scale, it's limited to a small size network. So health card method seemed like the perfect solution to our problem scenario. That's why we worked on this project. The system architecture consists of three parts. First is the client, the salesman. So he's a salesman Surakshitaru, and he needs to be updated continuously with the optimum route for carrying out necessary company services, etc. etc. So maybe he can have a laptop or an app where the route gets updated with the distance and how. Let's say like route planning, just with all the directions and stuff. The server controller technical support will get the requests and complaints and register them as the cities, target cities, the next cities the salesman has to travel. Payment gateway or transaction. It's a simple way, like once the customer gets his service carried out, he has to pay the salesman and it will automatically get updated, and then the city will remove itself from the list. So my friend Ishan will describe on the implementation part, but I will elaborate on is a little bit about the Google Maps implementation, what we have done here. In our scenario, the problem statement, as I said, we had to carry out the service agreement. So I made a real world scenario in what case how we can make this question understand via Google problem, Google Maps. So what we basically did is we mapped some random cities. Since I'm noticing, so I mapped some random cities in Odisha. I start from my hometown Jaipur, go to Fulbani, then Cuttack, then to Raigada, Siliguri, Balangir, Surat, Nayagarh, and then back to Jaipur as the question suggested. I had to return to the origin city. As you can see, this is the random route that's been decided to travel for the salesman in this case. So I prepared a cost matrix here with the distance between each city. I did not complete it because you get the idea of what I'm doing here. I'm trying to calculate the distance between each city to city, and I wrote the absolute distance here, and which is not only write the absolute distance, we can write the take into consideration various factors as I told earlier. We can notice that the diagonal elements here are 0, as the distance between the same city should logically be 0. So cities Cuttack is 0, Raigad is 0, Siliguri is 0, and so on. But most importantly, we have to note that the cost matrix can be asymmetric, as I said. So here we see an example of when we go from Fulbani to Jaipur, the least distance, we're not doing the maximum distance, the least distance is 377 km. But when we are going from Jaipur to Fulbani, it decreases to 363 km. This can happen due to various reasons, sometimes due to traffic and stuff, alternate route, weather and foggy climate, etc. We can take each and all things of this stuff into consideration. That's not much.
Implementation details. For implementation of our project, we used help curve algorithm, which is basically based on dynamic programming. Here you can see example problem of 4 noded graph with cost matrix, which includes distance between each city. There are 4 cities named 1, 2, 3, 4. We can observe that cost matrix is symmetric. That means distance between city 2 to 3 is same as distance between city 3 to 2. So in this we need to find out his tour with minimum cost. So we can say that T, which can be set with elements 1, 2, 3, 4, which are basically cities. To calculate minimum, we have to look different permutations and combinations. So for calculation, we are considering 1 to 2, 2 to 3, like that. Here minimum of about 3 paths is answer, but we know only the values of 1, 2, 1, 3 and 1, 4, which is basically we are considering very limited values. In real scenario, there are many values. Here is the recursive equation for our dynamic programming. So we are considering time with variables I and s. Minimum I of j and tj of s of j we are considering to be non-visited vertices. So this is the basic condition or base condition for this recursive equation. So if s is empty, that means we visited all the nodes, we visited all the cities. We take distance from that last visited node to first node, because after visiting all nodes he has to go back to initial node, which is basically initial city. Time complexity for this program. Time complexity of this program is big O of n is equal to big O of n square 2 raised to n. It is very less than other programming. So dynamic programming is suitable for traveling salesman problem or TSP. Since we are solving this using Held-Kalp algorithm, we know that Held-Kalp approach contains sub-problems. Here, after reaching ith node, finding remaining minimum distance to the ith node is the sub-problem. So we are considering here dynamic programming. So in the recursive equation, we are calculating for n-1 into 2 n-2 sub-problems. So therefore, our time complexity becomes big O of n 2 raised to n. Specs complexity is also number of some problems. So it's also big O of n into 2 raised to n. Novelty in our project. A novelty of our project is the introduction of asymmetric cost matrix or asymmetric distant matrix and its subsequent use in finding out the optimum route with ease. The compilation hardly takes seconds even if the values are very large. Our project also brings the clarity between cost and distance and why there are large number of factors which may contribute to large or smaller cost between each city on its reverse journey. Another novelty of our project is that there is a scope of enhancing this functionality into real server, which takes in the city names with clients requiring servicing. Our project also determines the real-time scenario, like we used Google Maps to check our project. So basically we studied dynamic programming using held-call algorithm for traveling salesman problem. Now let's see code implementation for held-call algorithm for traveling salesman problem. First, let's see pseudocode or algorithm for this. So we have to create one vector or matrix for input the values. So for dynamic programming, we have to create one variable to visit that node, and to try all the possibilities till the last we have to create some loops, and also we have to create some if-else conditions. So in the dynamic programming we need one recursive equation. Here you can see this previous and visited we used as recursive equations. Finally, we calculated maximum value as well as minimum value. So we used to pre-computed path lengths to choose our cheapest cycle to calculate minimum cost. So last equation is distance, which is distance with last answer and which is best answer. Run this code in compiler. So we created one matrix which is cost matrix, or which can be distance matrix also. So for that we created one function void get. So it will input the values with void mean cost. Using recursive equations, it will calculate the minimum cost for it or minimum distance for it. Using list method, it will calculate the minimum cost for total cities. And finally, in main method, we are printing our path. So let's run this code with real-time scenario. First, it will ask for enter number of cities. We can enter up to 8 number of cities, but here I am considering only 4 cities. So now let's put cost matrix, which can be distance matrix also. Using held call algorithm, we can use asymmetric matrix also. As here I am putting some asymmetric matrix with different values. So here we finally calculated minimum cost for our total journey. So there is a path for journeys: first city, then fourth, then third, then second, then first city. We also studied help call algorithm for TSP problem using MATLAB, which actually shows how much cost is reduced for different scenarios. So as you can see, this is the distance and this is the result. So cost is reduced here by different generations. So here is the distance is reduced and here is the percentage graph of reduction. So initial value is more than 120, and after that using help call algorithm it becomes less than 120. Conclusion and future enhancement. Our project's aim was to find optimum path and provide better solution to famous TSP problem. So we create workable solution with Sanskriti RO example, and we also create workable solution with Google Maps. So the minimum cost is the function of various factors like speed, distance, natural calamities also. So our code for our project is far less repetitive than branch and bound method, and in future enhancement there is a scope of elaborating upon heuristic algorithm like genetic algorithm and colony optimization, stimulated annealing. There are much more solutions for TSP problem. By using dynamic programming, we have made our solution for traveling salesman problem bit better by choosing smartly enumerated function calls rather than brute force algorithm, our way through every single possible path that our salesman could take.